Okay, so now we're going to do the definition of the derivative. So, from last class we discussed the rate of change of a linear function is given as the slope of its graph. It says if the graph is a curve, we can approximate the rate of change, or the slope. We start with a single point P and choose another point Q extremely close to P on the curve, and then find the slope of the line between the 2 points. If you choose 2 points that are extremely close together, your approximation will be as close to the exact value of the slope as you need. It says we call this the instantaneous rate of change at P, the derivative. So remember, the derivative is probably one of the most important things that you're going to learn in calculus. So we're going to want to make sure that we have a really good understanding of what this means. So what we're talking about here is that we have the slope of the secant line is exactly f of x plus delta x. That's small change right here, so delta x is the change, minus f of x over x plus delta x minus x. So remember, x plus delta x is just an ordered pair, so that's the x value, and then f of x plus delta x is the y value. So we can actually go through and we can simplify that, and what we would say is that we have f of x plus delta x minus f of x all over delta x. And what we're trying to do is make this delta x as small as we possibly can. That way it's as close and close and close. So we're P and Q right here. We want to get just as close as we can. So we're going to get like really, really close. So we're going to get closer and closer and closer and closer until we're infinitely close. So in order to do that, we take the limit as delta x approaches 0. That means the change is 0. We are literally right on top of each other. Okay? So it kind of reminds me of what we were doing last class when we had like the f of 8.01, then we did f of 8.001, and then we did all of that. So it would be like f of 8.001 minus f of 8 all over 8.001 minus 8. Do you guys remember doing that? And then we could put even more zeros and we get even closer and closer and closer. So it says, as Q approaches P, as we get closer and closer and closer, delta x is approaching 0. So we need to use our limit properties from before. So the definition of the derivative. The derivative of the function of f with respect to x is the function f prime. So the way that you say this is f prime. Okay? Whose value at x is. So this is probably one of the most important definitions you'll write down. The limit as h approaches 0 of f of x plus h minus f of x all over h as h approaches 0, provided that the limit does exist. So the notation for this is going to be, you've got a bunch of different ones. You've got y prime, you've got f prime of x, you've got dy dx, you've got d dt, and I'm sure we'll see a couple more along the way. Okay? So, it says the domain of f prime of x, which consists of all values of x on the domain for which the limit exists, could be smaller than the domain of f. It says, if the derivative exists, we say that f is differentiable at x. There are a couple of alternate forms of the derivative, which sometimes helps us in our application of doing the algebra part of this, because it tends to be just an algebra problem by the time we plug everything in. So we also have that the limit as h approaches 0 of f of a plus h minus f of a over h, or you also have f of x minus f of a over x minus a as x approaches a. Okay, and I'll show you how to use all of those. Okay, but it does tend to be just a basic algebraic problem, and then you just evaluate the limit. Okay? So it says use the limit process for the derivative to find the general formula for the derivative. So every time you're asked to do the derivative, you're going to write down the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, all we're going to do is plug in. It says f of x plus h. That means everywhere there's an x should go an x plus h. So, the limit as h approaches 0 of, and I'm going to put brackets around it, 2 times x plus h squared minus 3 times x plus h minus 2x squared minus 3x. Okay? All over h. So now it's all just algebra up top. So you need to go through and FOIL out x plus h squared, and then distribute, and then combine like terms. Which seems like it should be pretty simple, but we can make a lot of mistakes in the process. So we're going to start off with x plus h squared, which is just x plus h times x plus h. Hopefully we can memorize this by the time we're done here. Oops. I'm doing my memorized version already. So plus xh plus xh plus h squared. That's going to get us x squared plus 2xh plus h squared. And now we're just going to plug it right back in here. So we have the limit as h approaches 0 of, and I'm going to go ahead and distribute here. So that's 2x squared plus 4xh plus 2h squared minus 3x minus 3h. I'm probably going to actually drop this already. Might as well just bring it all together. So we have minus 2x squared plus 3x. So it's all about distributing correctly. All over h. So what we're going to do is try and find things that we can cancel out. So I have 2x squared minus 2x squared. I have minus 3x and positive 3x. And it looks like everything else has to stay. So we're going to write down the limit as h approaches 0 of 4xh. Oops. Plus 2h squared minus 3h all over h. Now, all this simplifying that we're doing is literally because we still can't plug in 0 because the denominator is just going to be divided by 0, and then we can't do that. So we're going to keep simplifying. So I'm going to do the lit as h approaches 0. And it looks like everybody has an h up top, so I'm going to get rid of it by factoring it out. My pen is being weird. Oh gosh. Let me see if I can fix this. 4x plus 2h minus 3 all over h. Now our h's cancel each other out, which means that everything is basically good to go. We have the limit as h approaches 0 of 4x plus 2h minus 3. Now I can go through and just plug it in. So I'm going to plug in. So it's going to go 4x plus 2 times 0 minus 3. And that's going to get us 4x minus 3. And then what function name was this? Just f? Let's look. So f, it says find the derivative. So this would be f prime of x equals. And you've officially found your first derivative. Good job, guys. It's a lot of work. It's very tedious, but it's the most concrete way of getting this. Okay? Now we're going to do the alternate form of the derivative. So, the alternate form of the derivative that I normally use looks like this. It would say the limit as x approaches a of f of x minus f of a over x minus a. Now I'm going to go through and find out what f of a is so that I don't have to show it plugged in over there. So I'm going to do f of 1 equals the square root of 3 times 1 plus 1. Square root of 3 plus 1, square root of 4 equals 2. Great. So now we're going to go ahead and everywhere that a is, there's going to be a 1. Okay? So the limit as x approaches 1 of the square root of 3x plus 1 minus 2. Oops. That's getting kind of weird. Minus 2 over x minus 2. Oh, I apologize. A is 1. Okay? Now let's go through and we're going to need to simplify. So this actually reminds me a lot of what we were doing when we were in the limits unit. So we're going to have to multiply by the conjugate. That's going to be 3x plus 1 plus 2 and 3x plus 1 plus 2. Now up top, remember we're supposed to go through and just simplify it. So remember we did this for a reason, so they're going to cancel each other out up top. So it's going to go to the limit as x approaches 1 of 3x plus 1 minus 4 all over x minus 1 times 3x plus 1 plus 2. Okay, now we're just going to simplify up top the limit as x approaches 1 of 3x minus 3 over x minus 1 times the square root of 3x plus 1 plus 2. Now, this should all be stuff that we know how to do. Now, is it kind of annoying? Yeah, for sure, it is. But we should be able to do it. So the limit as x approaches 1 of 3 times x minus 1 all over x minus 1, 3x plus 1 plus 2. Okay, then I'm going to go through and I'm going to cancel these out. Wonderful. And then I'm going to end up with the limit as x approaches 1 of 3 over the square root of 3x plus 1 plus 2. Now, I don't have any issues with plugging in, so I'm going to go through plug in, and I'm going to drop the limit notation. So 3 over 3 times 1 plus 1 plus 2, which is 3 over the square root of 4 plus 2. 3 over 2 plus 2, which is 3 over 4. Does it ask us anything else? Find f prime of a. Okay, equals f prime of a was 1, I believe. Yep. And there you have it. Okay, so it does get a little tedious in the process, but it's really not as bad as you think it is, okay? Alright. So, now what we're going to do is we're going to go through and look at the next example. So it says, for the function f of x equals x squared minus 3x plus 2, find the general formula to any point on the curve. Use the general formula. So, if it doesn't give me one that I need to use, like use the alternate form, I'm going to just use the regular one. So it says the limit as h approaches 0 of f of x plus h minus f of x over h. Okay? And now what we're going to do is we're going to plug it in. So I'm going to go ahead and plug it in. So the limit as h approaches 0 of x plus h squared minus 3 times x plus h plus 2 minus x squared minus 3x plus 2 all over h. Okay, so I'm going to pause and go ahead and simplify up top, and I'll show you my next step, and then I'll pause and simplify some more. Alright, and here we have everything all FOILed out and ready to go. Now I just need to combine my like terms. So I'm going to go through and I'm going to cross out everything that needs to cross out. X squared minus x squared minus 3x plus 3x plus 2 minus 2. Alright, that gives me the limit as h approaches 0 of 2xh plus h squared minus 3h, oh, that's it, all over h. Okay, now I'm going to go through and up top, remember our goal is to be able to cross out this h in the bottom, so we can take out an h from the top. The limit as h approaches 0, factor out an h up top, 2x plus h minus 3 all over h. Cross out the h's, how nice. Now we have the limit as h approaches 0 of 2x plus h minus 3. Now we get to just go straight ahead and plug it in. So that's 2x plus 0 minus 3, which gets us f prime of x equals 2x minus 3. Great. Now all we need to do is just plug in where they said at x equals 2 and x equals 0. So, f prime of 2 here's 1, and then we just need to do the last one, f prime of 0 equals 2 times 0 minus 3, 0 minus 3, negative 3. Alright, great job. Okay, now this one says use the limit definition to compute f prime of a, find the equation of the tangent line. So when I see a, my usual instinct is to go through and use this definition. The limit as x approaches a of f of x minus f of a all over a, oh, I'm sorry, all over x minus a. Okay, now we'll go through and we'll just plug in what we have. So we should actually find out what f of a is. So f of a equals 1 over negative 2 plus 3, 1 over 1, which is just 1. Okay, great. Alright, so now we'll do the limit as x approaches negative 2 of 1 over x plus 3 minus 1 over x plus 2, because it's x minus negative 2. Okay? Now I know how you guys feel about complex fractions, but we're just going to have to deal with it. We're going to have to get good at this. So we're going to multiply by x plus 3. Whoa, 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 whoa. X plus 3 on the top and on the bottom. X plus 3. Now we're going to distribute here, and they cancel. So the limit as x approaches negative 2. So here and here they cancel, so that's 1 minus. Then you distribute here, there's nothing to cancel with. So 1 minus, or minus 1 times x plus 3. On the bottom, everything just stays, so x plus 2, x plus 3. Okay, now we're going to keep going, so the limit as x approaches negative 2 of 1 minus x minus 3 2 times x plus 3. Alright, now we're going to keep going. So the limit as x approaches negative 2 of negative x minus 2 over x plus 2, x plus 3. I know this is very tedious. I get that. I agree. Okay? But now what we're going to do is we can factor out the negative up top, and then we'll get to cancel things out, and everything will be much nicer. Okay? So now cross out, cross out. I'll bring us back up here. We have the limit as x approaches negative 2 of negative 1 over x plus 3. Okay? So now we get to plug in negative 2 and drop the limit notation. Negative 1 over negative 2 plus 3, which is just negative 1. Lots of work for just negative 1. Now it wants us to do the equation of the tangent line. So they want y minus f of a. So y minus, and here's f of a. So y minus 1 equals, now this is the slope that we found the slope of the tangent line is negative 1. So negative 1 times x minus negative 2, so plus, and we don't have to do anything more than that. Okay? That's why we were talking about at the beginning of the year, we said that sometimes you need to know how to do the equation of a line. There's no need to do more work than that, but just write it just like that. Okay? So this one says use the alternate limit definition to find the equation of the tangent line. So, there are two ways that we can do this. So we have two alternate definitions, and I'm going to show you both. And I'll tell you why one might work better than the other one. So I told you my favorite one. My favorite one looks like this. The limit as x approaches a of f of x minus f of a over x minus a. Now this one is x, or I'm sorry, this one is a, and this one is f of a. Okay? So if you were to do this, you would say f of x, so that's the limit, as x approaches a, or x approaches 1, of x cubed plus 4x minus f of a, which is 5, all over x minus a, which is 1. So the problem is you can't plug 1 in here. Another problem is you don't know how to factor something that says x cubed plus 4x minus 5. Our only assumption is that x minus 1 must go in there because that's the only way to fix it. However, I don't think that you really want to go through and try to factor that. There are other ways, but I have a feeling that you're not going to remember that. So instead, we can use the other definition. So the other alternate definition is the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay? This one's going to avoid having to do any of the things I was talking about might be an issue before. Okay? I personally like the left one, but I don't think that you're going to like having to try to figure out how to factor the top part. Okay? So instead what we'll do is we'll use the one on the right. So what that means is that we have to go through and we have to do f of 1 plus h minus f of 1. Okay? This is what it looks like. So the limit as h approaches 0 of f of 1 plus h minus f of 1, P.S. we already know that it's over there, over h. So what we have to do for f of 1 plus h, I'll write it over here because it gets to be kind of long, f of 1 plus h, is we have to do 1 plus h cubed plus 4 times 1 plus h. The second part is not so hard. The 1 plus h cubed is kind of hard. Only difficult in that I'm sure that you do not remember learning a pattern in order to do this problem. I don't know if you remember, I think it's called Pascal's triangle, 1, 3, 3, 1, but that's okay. We can just multiply it out. So we have 1 plus h times 1 plus h times 1 plus h. We have to do these two at a time, so we're going to do these two first. It's going to go 1 plus, so 1 times 1 times h, and then 1 times h again, and then h times h. Okay, so that gets us 1 plus 2h plus h squared. Now we need to multiply that by 1 plus h. Okay, that's 1 plus 2h plus h squared. Okay, now we'll do the h. So distributing the h, 1 times h plus h plus 2h squared plus h cubed. Okay. I'm going to combine like terms here. H cubed is going to go first. Check. 3h squared. Check. 3h. Check. And then plus 1. Okay? And then I'm just going to bring this part back over. So, what we have now is the limit as h approaches 0 of h cubed plus 3h squared plus 3h plus 1 plus 4h plus 4. Oh, I put that in the wrong order. Plus 4. That's okay. And then minus f of a. F of a is right here. Minus 5. All over h. So, now we need to look very carefully. Are there things that we can get rid of? So, h cubed, there are no other h cubes. 3h squared, there are no other h squareds. Oh, 3h and 4h can go together. And then it looks like I have plus 1 plus 4 minus 5. That's 5 minus 5. Okay? Now I'm going to go through and rewrite the limit as h approaches 0 of, now we have h cubed plus 3h squared plus 7h all over h. Okay? Now we're going to go through and factor out an h, that way we can get rid of this h in the bottom. So, the limit as h approaches 0 of h times h squared plus 3h plus 7 all over h. Cross out, cross out. Now we have the limit as h approaches 0 of h squared plus 3h plus 7. So we're supposed to plug them all in. So 0 squared plus 3 times 0 plus 7. Answer is 7. Now let's double check we've answered what it asked for. Oops. Use the alternate to find the equation of the tangent line at. So we haven't done the equation of the tangent line, we just have the slope of the tangent line. So the equation of the tangent line is going to go y minus because y minus y1 equals 7 times x minus 1, and that's it. Okay, you've done it. Nice job. So this one doesn't tell us how to do our derivative, so you get to pick. I'm going to use my regular definition. So I'm going to do the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? Now, I'm going to go through and plug this in. I'm going to pause for the entire thing. Okay, so I'm going to have it all done, and you'll have it all done, and we'll double check with each other. Remember, it says equation. Okay? Alright, and there we go. So we have, I ended up getting negative 32x plus 96 as my derivative. Okay, and I can label it that way. F prime of x equals, and then it asked me at 180, so I plugged in 1, and I got my slope of 64. So I put 64 in my slope location right here. Oops. And then I use the point 180 in point slope form. Okay? Alright. Now, let's look and see about the last one. So it says find g prime of t for the function g of t equals 1 over t squared. So I'm sure that you know, and you can probably already tell, we're going to have to deal with complex fractions. So we're going to do the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? Now it says g of t, but I'm just going to use x's instead, and I can put t back. Okay? So it says f of x plus h. Okay, so we have the limit. Oops. Oh, I'm using the eraser. Okay, the limit as h approaches 0 of 1 over x plus h squared minus 1 over x, because I decided to use x squared because I decided to use x's, and we can put the t's back in a minute, over h. So, things that we'll need x plus h squared, and we'll need another x squared. Okay? So, in my first one, my first fraction here, when I go to basically kind of distribute here, my x plus h squareds cancel each other out. So that gives me the limit as h approaches 0 of x squared minus, now these x squareds cancel each other out, this one and this one. So we have x plus h squared all over, now you have to do the bottom part too, x plus h squared and x squared. Okay? So, what we're going to do is we're going to rewrite it as x squared h times x plus h squared. We're going to leave the bottom as is and hope that the top can help us simplify it. So, what we have up top is the limit as h approaches 0 of x squared minus x squared plus 2xh. Oh, let me fix that. That's h plus h squared all over x squared h times x plus h squared. Okay, now I'm going to go through and make the top all nice by distributing the limit as h approaches 0 of x squared minus x squared, oh that's good, minus 2xh plus h squared all over x squared h, x plus h squared. Okay. Now we'll cancel stuff up top, hopefully. X squared minus x squared. The limit as h approaches 0. Now, since we've done this a lot, I know at the top I need to factor out anyway, so I might as well just take out an h. Now you have h minus 2x. I just reordered these, okay? And then I have x squared, h, x plus h squared. Now what we should notice is that this x and this x can cancel. And then we'll have the limit, blue, the limit as h approaches 0 of h minus 2x over x squared times x plus h squared. Now I can actually go through and plug in this 0 because that actually doesn't mess anything up in the bottom here because it would just be x plus 0. Okay? So we get 0 minus 2x over x squared times x plus 0 squared, which simplifies to negative 2x over x to the 4th, which simplifies to negative 2 over x cubed. And then did they ask us to do anything else? They said find g of t, so we should probably put it back to the letters that they want. So it would be g prime of t equals negative 2 over t cubed. And now you've done it. Great job, guys. Thanks for watching. This was a long one.